Bismillahirrahmanirrahim. Assalamu alaikum viewers and welcome to my channel. And in today's video, as you can see the topic here, we are going to discuss the transformation of functions graphs with respect to horizontal and vertical shifts. So what is the exact methodology that one should follow when they are performing such kind of shifts, the horizontal or vertical shifts? So the layout that we have to keep in our minds regarding these shifts, how we are going to understand, let's see over here. If I talk about my horizontal shift, okay, if I'm having a certain function and I want to shift it horizontally, then I'm going to shift it horizontally, when I'm going to shift it vertically, what are the signs that I'm going to observe in the function? That is the thing that we are discussing right now. So if you're having a certain function and the graph of that function is in your mind, or you might have sketched it somewhere, either on a graphic calculator or by making a certain manual table, and then you are sketching it on a piece of paper. So the shape of the graph of this function f of x is in your mind, okay? It might be in front of you. If I just say that wherever you are having x in that function, you are replacing that x by, for example, by your x plus c, okay? Something like that. So if you are observing that you are having a certain change in that function wherever you are having x out there, what you are going to do, that if your c is negative, I mean if it is having a negative value, if it is less than 0, then you shift your graph towards your right. Shift your original graph or the graph of your f of x towards your right, okay? C units towards right, okay? And if the value of your c is positive, means if it is greater than 0, then you shift your graph of f of x c units towards left, okay? I'm not writing the full sentence. I hope you understand that. This is it. Let's pick up an example related to this in order to understand it more deeply. For example, I take my f of x as my Euler exponential function. I just take it this. Okay, this is my f of x. So you can get the graph, shape of the graph, or the form of the graph. You can understand that either by plotting the same function on the graphic calculator, or by manually performing the graph sketching on the piece of paper by making some table, picking some values, either 5 or 6, and you just get the excuse me, you just get the value of your dependent variable y by putting some independent variable values of x. You just get some ordered pairs, you plot it on a piece of paper, and you just get a graph form, okay? The shape of the graph, however it looks like, whatever it looks like. So I just use here my Untitled graphic calculator, and the shape of your exponential function, once you plot its graph, how it looks like, let's see. Okay, so I hope you can see this graph. There you go. And this is representing this function. I hope you can see it. Okay, this is the exponential function, and this is my Untitled graphic calculator. So you see, this is a graph of this exponential function, how it looks like, and you can see here that at the origin The value, if the value of your x is 0, then the value of your corresponding y is 1 here. Okay, that's it. You can see. Alright, so we have to keep this shape in mind, and let me sketch the same curve on a piece of paper. Alright. Okay, so this was the function that we are discussing here right now. We just observe its graph on the graphic calculator, and then we sketch it as it is on a piece of paper right over here. Okay, so this is the curve of your exponential function, Euler function. Okay, so that's how it looks like at the value of x0. If your x is 0, then the corresponding y coordinate is 1. All right, this is it. Now how about if I just at the place of my x, I want to replace this x by my x plus 2. Okay, so you see, actually this is your function x plus 2, the function of x plus 2. So wherever you find your x, you're going to replace it by your x plus 2. Okay, so that's how your function now it looks like this, in this form. What is going to be the shape of the graph now? Okay, so what you do, actually, you can see here that your c is positive. You can see that the value of your c is 2 and it is greater than 0. So if your c is greater than 0, then you shift your original graph c units towards your left side. So you see, you're going to shift your graph 2 units left. Okay, this is going to be your point. All right, this is going to be your point. So what you do, you're going to draw an imaginary reference frame of axes. Okay, so over here you're going to draw an axis like this. Hang on, let me draw. You see, your x-axis in the new frame of reference, with respect to the new frame of reference axes, your x-axis is same to that of the original one, but your y-axis has been shifted, it has been changed, and it has been slide up 2 units towards left. Now this is the new y-axis, and this is the x-axis is going to remain the same. So now this is the new frame of reference. In this respect, you are going to plot your point. So now this time, this point is going to behave as your origin. It is going to behave as a new origin. I'm going to represent it with my O dash, for example, just for understanding. Okay, so now you can see that how my graph of this function looks like. The shape will be kept maintained. You can see that at the origin, if your x is 0, then the corresponding y value, y coordinate is 1, and so on. You're going to follow the same pattern, draw the same curve, and that's how it looks like. Let me draw. Okay, that's how it looks like. Okay, so this is the graph of your this function. Okay, that's it. That's it. This is something that you call horizontal shift. Okay, now how about if I say that if I take my f of x by f of x minus 2. All right, so this time my function is going to be defined like this. At the place of my x, at the place of my x, I'm going to put down my x minus 2. This time your c is minus 2. It is less than 0. So you're going to slide up your y-axis, the original y-axis, 2 units towards your right. Okay, but this time your new y-axis is going to be drawn over here. Okay, over here, 2 units towards your right. Just like this. Okay, now this is the new frame of reference, is now having its x-axis over here at starting at this point, and I'm sorry, in the new frame of reference your y-axis is going to be positioned at this place. Okay, and x-axis will remain the same, and origin is now has been slided up from 0 to this position, the point where you are having your 2, okay? And now this is my new origin point. In this respect, I'm going to draw my exponential function graph. This is the original form. Slide up this graph over here such that it is going to look like this. Hang on. Okay, and this is your f of x minus 2 equals to exponential of power x minus 2. So that's how you do it. This is, you see, once if you're having your c value positive, you just move your graph to the left, c units times towards left. And if your c is negative, then you slide up the same graph c units times towards your right. So that's how you do, all right? So this is the way how you perform the horizontal shift. Now in the same manner, we are going to understand what exactly a vertical shift is. Okay, before moving to the vertical shift, I thought that I must authenticate or I must confirm the horizontal shift graphs that we made on a piece of paper out there. You see, this was the curve, this is the curve of your function e of x, okay, e power x. And when I shift it 2 units left following this function e power x plus 2, it looks like this. So we were correct. In the same way, if I just plot the graph of your f of x minus 2, that will be e power x minus 2. Let me write it down. This is the third graph, and you can see that this is your it has been shifted 2 units towards left because the c value was your less than 0, it was negative 2. There you go. Okay, it was negative 2. So the third graph, you can see that it is 2 units shifted towards left, okay, towards right, I'm sorry. This is it. This is your 2, okay, and this is going to behave as your origin, and at a new origin the y coordinate is 1, and this is going to be your graph. It has been shifted 2 units towards right. If your c is less than 0, then the graph is going to be shifted c units towards your right. And if c is positive, then the original graph is going to be shifted 2 units towards your left. So that's how it looks like, okay? Well, let's move ahead towards your vertical shift, okay? And let's see a few examples. For example, we have to understand the method. Okay, so let's have a look. Okay, so in vertical shift, what you do, if your f of x is replaced by f of x plus c, okay, if you're having a form like this, that in the original function, if I simply add up some value, then you're going to perform the vertical shift, okay? If I add or subtract any value from your function, original function, then in that case you have to perform the vertical shift. Okay, so and if the change is inside the independent variable of your function, the function which is defined, the variable which is defining your function, if the change is out there, then you perform horizontal shift. And if something is added and subtracted outside the function, you perform vertical shift. Okay, so if the first property, that if your c is less than 0, means if it is negative, then original graph, then graph of your f of x is shifted c units towards not towards, I must write downwards. Okay, I'm sorry. C units downwards. Okay. And if, for example, if your C value is positive, or it is greater than 0, then the graph of the original function of f(x) is going to be shifted C units upwards. Okay, that's how it is performed. That's how you do the vertical shift. Okay, like if your C is greater than 0, if it is positive, then the graph of your f(x) is going to be shifted C units upwards. Okay, C units upwards. Alright, this is it. Now let's have a look to the example. We are going to pick up the same function e of x here, because we have just took that. We have just taken that. So this is it. This is your function, and we have just we have just seen that how the graph of this function looks like. Well, that's what our graph of exponential power x, that's how it looks like. So now if I just do something like this, that if I just add 1 in this function like this, so it is going to be my f of x is my e power x, and this is it. So we are adding 1 in it. So here you can see that the value of your C is 1. It is greater than 0. So you are going to shift the same graph vertically upward, 1 unit upward. So over here, you're not going to change your y-axis. It will remain as it is once you're going to once you're going to maintain a new frame of reference or new set of axes. So, or a new 2D coordinate plane. So in that new coordinate plane, your x-axis will remain, your y-axis will remain same. Your x-axis will be shifted 1 unit upward. Okay, so it is going to be drawn right over here. So let me draw it exactly like this. Okay, so you see your x-axis has been shifted 1 unit upward because your C was greater than 0. So the graph is going to be, the original graph of your f of x is going to be shifted C units upward. So that's why you just shift your x-axis 1 unit upward, because the value of your C is 1. So C units means you have to shift it up to 1 unit upwards. So this is now the new frame of reference is having y-axis this, and x-axis is this green one. Okay, this green one is the x-axis, and this is going to be my origin, my new origin. I just name it O dash or 0 dash, okay, for understanding. So now the same graph, I'm going to the same curve I'm going to draw and the same pattern, and let me assign the units as well. Okay, so I've just maintained the units as well on the new x-axis. So let us now form the curve. This is going to be, have to be very careful. At 0, you're having 1 unit in the y-axis, like this. Okay, so this is it. That's how you perform the vertical shift and your f of x plus 1, which is your e of x plus 1. Okay, that's it. In the same manner, I hope it is clear to you. Now, in the same way, if I just subtract some value with my f of x, let us take it 1 unit subtraction, it looks like this. Okay, and this time the value of your C is minus 1, it is less than 0. So you're going to shift your x-axis, the original x-axis, this black one, 1 unit downwards. Okay, because you're having 1 unit here, the C value is 1, so 1 unit downwards because it is negative. So let us draw a new x-axis here, which along with this positive y-axis, original one, is going to form a new frame of reference, a new coordinate plane. Okay, So as I told you that in vertical shift, your x-axis, y-axis will remain fixed. X-axis is going to slide up here and there. And in horizontal shift, your x-axis will remain fixed and your y-axis is going to be slide on the left and on the right. Okay, it is going to swing to and fro like that. Okay, so let me draw now the new axis. Here you go. So I have just shifted I have just slide my x-axis 1 unit downwards. Okay, now this time this point is going to behave as my origin, my new origin. I just name it as my 0 double prime. Okay, now I'm going to draw my sketch. I'm going to draw my same curve with respect to this y and this x-axis. Okay, this is my origin. So if my x is 0, then my y, corresponding y, is going to be 1 unit upward. It's going to be over here. Okay, so my new points are now these. Now let me join. Okay. Like this, and this is your f of x minus 1, which is e power x minus 1. Okay, so that's how you perform the vertical shift upwards and downwards. Let's authenticate, or let's confirm, are these shifts that we have just done over here and we just sketched over here, are they really correct or not? So let's see through our graphic calculator. Here you go. So you can see that this middle curve is the curve of our exponential e of x, the original curve, which is represented by this function e power x. Okay, and if I talk about my e power x plus 1, the corresponding graph is this 1 unit above, it is this one. Okay, and the graph representing e power x minus 1 is 1 unit downwards. You can see it is this. Okay, they're exactly same how we did on that paper, so we are right. So the strategy that I've just explained to you is 100% correct, so you just follow it and you'll gain grip in it. Okay, so now let's see two examples in a combined form, the example in which you have to do both horizontal and vertical shift. All right, let's have a look. Okay, now here you can see this is the function that you have to, in which you have to perform horizontal and vertical shift. So this is a combined form. In this form you have to perform both horizontal and vertical shift. For that purpose you have to assign your original f of x, which segment of this right hand side can behave as your f of x. So I'm going to take it, and definitely it is this time, that your f of x is negative e power x. Okay, so this is your e power x. Over here we are going to plot your graph of negative e power x over here, and then we are going to perform the horizontal and vertical shift over there. If this is your e of x, then f of x minus 1, according to this, is going to be interpreted as this. Okay, and here you can see that if you just try to compare it with the general form, here you can see that your c is minus 1 here, so it is less than 0. So you are going to do what? You're going to shift horizontally, you're going to shift your graph 1 unit towards right. Okay, so 1 unit towards right, that's what you're going to do. Horizontal shift will be 1 unit towards right. Okay, and here in this function f of x is added 1 here. If I add 1 here, it's going to be e of minus e of x plus 1. Okay, So this time, if you compare it with your general form, your c is 1 here, it is greater than 0. So this time the vertical shift will be 1 unit upward. Okay, so 1 unit towards right, I forgot to write a unit here, 1 unit towards right and 1 unit upwards. That point is going to be your origin, your new origin. Okay, so this is a description. Let's see to the graph. Okay, so this is the graph of your negative e power x. Okay, this is it, and that's how the graph looks like. All right, you can form the graph either in a manual way by forming the table, or by the graphic calculator. That's your choice, which method you're opting, or which source you're opting. Okay, now as far as the new origin is concerned, that you have to find out the new frame of reference, the new frame of axes, or the new reference frame that you have to draw. What is that new origin over which you have to draw that new coordinate plane or new coordinate axes? As I told you over here, you shift 1 unit right, 1 unit upward. This is the origin. Okay, this is the new origin, this is the original origin, initial origin. 1 unit right, 1 unit upward. So this is going to be the point, this is going to be the position of your new origin. Okay, this is your new origin position. Over here you're going to draw the new set of axes. Okay, here you go. Okay, we have just formed new frame of reference, a new set of axes with respect to this new origin that we so decided on the basis of this function form. Okay, so I've just assigned here the units. You can see over here. In the same way, I'm going to assign the unit with respect to this origin on the y-axis, the new y-axis as well. Okay, that's how we do. All right, so I told you that in this graph, at x value 0, your y coordinate is going to be -1. So now this is your new origin. So if your x is 0, the y coordinate will be 1 value. I'm sorry, this is your -1. This is -2. This is -3. This is -4. This is -5. So if your x coordinate is 0, then y coordinate is going to be -1, which is position over here. Okay, now let's do it. It's going to be, let me use a different color. Okay, now that's fine. Okay, that's how the stuff looks like. Okay, that's how the stuff looks like. Okay, so this is the graph of this function. Okay, this is the graph of this function. You perform the horizontal and vertical shift all together. So that's how you do. Okay, this is the curve representing this format. Okay, so let's confirm, are we really correct or not? Let's go towards the graphic calculator. There you go, 100% we are fine, because this curve, this below one, the downwards one, this one is representing this function. It's representing this function, -e power x. I hope you can see it. Okay, and you can see the second function as well right below of it, the graph of this function is this, the curve heading upwards like this. So it is with respect to the new frame of reference that we designed in that our piece of paper over there. So this is it. It means we are correct. So our strategy of performing the horizontal and vertical shift is just fine. Okay. Let's see one more example. I'm sorry viewers, because lack of timing I'm unable to continue this video. So the remaining portion is going to be covered in the next part of the same topic. So that's all for today. So if you find this video helpful, I appreciate if you please subscribe my channel and hit on the like and share this video as much as you can with your other learners. Take good care of yourself. Allah Hafiz.